right. Today we are pulling back the curtain on the tech that's, well, it's absolutely everywhere. Large language models. We're going to go way beyond the hype and really start asking some tough questions about what is actually going on under the hood. So get this line about a refrigerator dreaming in code, that was written by an AI. It's kind of poetic, right? It's creative and honestly a little weird. And this is exactly the kind of thing that has so many of us convinced that these models are genuinely intelligent. I mean, they write emails, poems, they even write code. The power it's just undeniably impressive. And because of that, it really does feel like we're standing at the dawn of a completely new age. You can feel it in the air, this sense that these intelligent machines are about to change pretty much everything. How we work, how we create, maybe even how we think. The excitement is totally real. But, and this is the big question for us today, what does intelligent even mean here? You know, if we actually look past the fancy language and get under the hood, we find some pretty fundamental flaws that are frankly crucial for all of us to understand. So let's start with the thing we all interact with first, the output, the stuff they actually generate, because this is where the first cracks really start to show. The first big one, and you've probably heard about this, is what people call hallucinations. Now here's the most important part. An LLM is not designed to be truthful. It's designed to generate text that sounds plausible. It's built to look like something a human would write. And that means it can, and very often does, just make things up, complete falsehoods, but it states them with the unwavering confidence of an expert. Because all it's doing is predicting the next word in a sentence, not checking if that word is, true. And this really gets to the heart of why they make these mistakes. See, LLMs are absolute masters of syntax. They know the rules of grammar inside and out, but they have zero grasp of semantics, the actual meaning behind the words. Think of it like a parrot that can perfectly mimic a complex sentence, but has no clue what it's actually saying. It's just incredibly sophisticated pattern matching, not real understanding. Now, a lot of these output problems really stem from a much deeper issue, the input. An AI is only as good as the data it was trained on. And let me tell you, that data comes with some serious baggage. These models are trained on a massive, giant snapshot of the internet, with all its brilliance, yeah, but also all of its ugliness. And what that means is that every bias, every stereotype, every prejudice that's out there in that data gets learned and then repeated by the model. So it doesn't just reflect our biases back at us, it can actually amplify them. And then you've got the memory issue. Every single LLM has a hard limit on how much it can remember at any given time. It's called its context window or a token limit. And any part of your conversation that falls outside that little window, poof, it's gone, completely forgotten. The result is, well, it's just like talking to someone who's brilliant, but has severe short-term memory loss. You could be having this deep, complicated conversation, but after a couple of pages of text, the AI has literally no memory of what you said at the beginning. It's a fundamental roadblock to its ability to truly reason through complex problems. Okay, so finally, let's zoom out to the biggest set of challenges, the problems that are baked into the system itself, from its hidden internal logic all the way to its staggering real-world costs. This one's a big deal. These models are so unbelievably complex, with billions and billions of connections, that they are, for all practical purposes, black boxes. Even the brilliant engineers who build them can't really tell you why it gave you one specific answer instead of another. We know what goes in, we see what comes out, but the why in the middle, it's a total mystery. And that black box nature creates some really serious security risks, like something called prompt injection. So here's how it works. A bad guy hides malicious instructions inside a document or a web page. Then, when you ask your AI to, say, summarize that page for you, it gets tricked into following those hidden commands, and it could end up leaking your private data or giving you a compromised answer. And we just can't ignore the cost. $700,000, and that's a conservative estimate for how much it costs to run just one major AI service for one single day. The amount of money, computing power, and energy needed to keep these things running is just mind-boggling. So, after hearing all that, is it just doom and gloom? No, absolutely not. Understanding these limitations isn't about trashing the technology, it's about learning how to use it safely, how to use it effectively, and how to use it wisely. So, here are the key things to remember. First, treat AI like a powerful tool, not an all-knowing oracle. It's a brilliant but flawed assistant. That means you have to question and verify its output, always. Also, be aware that its answers might be shaped by hidden biases in its training data. Remember that its memory is super limited. And finally, recognize the huge costs and security risks humming along behind that simple chat window. Which leaves us with one final thought. Look, this technology isn't going anywhere. It's becoming woven into the fabric of our lives. So the real challenge for all of us is to move beyond just asking it for answers. We have to learn how to think with it, how to use it as a tool that sharpens our own critical thinking. So the question is, how do we partner with this technology, flaws and all, to become smarter? It's a question we're all going to be answering together. Thanks for joining me.